Hello, now we are moving on to AQA GCSE Chemistry 3, Metals and Acid. Ooh, acid. Anyway, let's get this started. Okay, so what exactly is an acid? So let's go down here and have a look. Acids are shown on the scale, the pH scale. The closer it is to 0, it's more acidic, and the closer it is to purple, it's more alkaline. So these are strong acids, those are weak acids. Acids have H plus in them, whereas alkalines have OH minuses. A base is a chemical that neutralizes acids, and an alkali is a water-soluble base, and it's here. So an acid plus a base equals a water and a salt. So for example, if you got hydrochloric acid and added sodium hydroxide to it, you would get sodium chloride and water. Sodium chloride being the salt and water being the water. That is as the H plus and the OH minus make a H2O. So that's how the acid part of the acidic part of the acid gets taken away and turned into a salt, which is no longer acidic. So that's how acids and bases, which are basically alkalis, go together to neutralize. So, the main topic, metals and acid, they're the reactants, and salt and hydrogen are the products in this reaction. So for example, if we use sodium as the metal and nitric acid as the acid, sodium plus nitric acid turns into sodium nitrate plus hydrogen. As you can see up here, how this works, hydrochloric acid, it will become a chloride. Sulfuric acid, it will become a sulfate. Phosphoric acid, it will become a phosphate. And nitric acid, like here, it will become a nitrate. So we've seen about what metals were in the previous videos. But how do we get metals? So this is through the methods of extraction. So ore burning is a way to get some very common metals, which are literally just found as ores, such as the ones right down here, gold, silver, mercury and copper. But anything more reactive than hydrogen and less reactive than carbon, because it's less reactive than carbon, carbon can be used to displace it. So for example, iron is there. So iron oxide plus carbon turns into iron plus carbon dioxide. So by doing this, we've managed to extract the iron as a pure substance because it's lower than carbon. So the oxide will turn into dioxide and go with carbon because it is more reactive. But what if it's more reactive than carbon? Well then, we have to use another method known as electrolysis, which splits substances using electricity. And it's used for more reactive substances than carbon. Also, some substances are just mined as pure metals, such as gold and silver. I think ore burning might have been slightly higher up than I said. I think it might have been things like mercury and copper, whereas gold and silver are mined as pure metals. So, oxidation and reduction. Oxidation is the losing of electrons, and it happens due to the adding of oxygen to a metal. So if magnesium is combined with oxygen, it makes magnesium oxide. And due to that, electrons are taken away, as the electrons need to form a full outer shell. So reduction is the gaining of electrons, and it happens when you remove oxygen from a metal. So this can happen when you use a stronger thing on here, such as carbon. So you'd say copper oxide plus carbon turns into copper plus carbon dioxide. Carbon is more reactive, so displaces copper. That's how it works. So reduction is basically if you're removing oxygen, so you're taking the oxygen away by combining the oxygen with the carbon instead. And this can work with multiple metals. For example, something like magnesium you could use to displace even something one lower like aluminium, and then the one that becomes an oxide or a dioxide is the one that gains oxygen and loses electrons. But the one that loses oxygen and stops being oxide or dioxide, reduction happens, which means it gains electrons and it removes oxygen from a metal. So yeah, that was metals and acids. So yeah, goodbye.